Welcome back. Today we will be talking about calculating test statistic with one mean hypothesis test. In your textbook, you have a detailed explanation of how to do it mathematically. I'm not going to be talking about mathematical procedure today. We will be using class calc and try to find out our test statistic. All right. Okay, let's recap. How do we start? So to compute the value of a test statistic, which is the z value, the z score, right? For a hypothesis test of one population mean and unknown standard deviation. These are very important because based on what information you have, you will be using different tests. In this particular case, you have population mean with a known standard deviation. That means you do know a standard deviation of the population, and you have one population mean. You do have a population mean, and you know the standard deviation. So when you know both of these, you will be using a z-test. Okay? All right. Which is the z-score? Step one, always, you start with your ho, ha. Ho stands for null hypothesis equal to. So if you have the word at least, at most, no more than, no less than, those are your null hypothesis. Your alternative, greater than, less than, not equal to. So you write your null and alternative, and your step two is your alpha. Your alpha is you cannot come up with it. That is given to you. Keep in mind what is your alpha? Your alpha is type 1 error. That is the probability that your null hypothesis is true, but you reject it. That is your type 1 error. Remember, in statistics, you only focus on your null hypothesis. This is the main important thing. Either you prove this is true or this is false, right? So alpha is the probability that your null hypothesis is true, but you reject it. Step three is to compute your test statistics. So this is what we will be doing today. We will be doing step three. So we did talk about null hypothesis and alternative in the previous section. Alpha is always given to you, so you don't have to do anything. Now we're moving on to step three, which is calculating your test statistic. Okay? So this section is about how to calculate your test statistic. The next section will be once I have the test statistic, I will compare it with my p-value. The next topic will be once I compare it, how do I conclude? All right, so let's go ahead. This is the formula to calculate your test statistic. You have to know each and every term. The X bar stands for your sample mean. Remember the whole concept of your hypothesis testing. If you want to prove or disprove something, you take your sample. The sample is the key, right? But depends on where you took your sample, how you took your sample. Based on that, you will infer. So once you take your sample, you have to take your sample mean, and this n stands for your sample size, right? Your mu stands for the number of population, the population mean, right? And sigma stands for standard deviation. All right, so once we know our sigma, once we know our mu, once we know our n, which is the sample size, let's go ahead and jump into the problem. Suppose a chef claims that her meatball weight is less than 4 ounces. So she's claiming the meatball weighs less than 4 ounces on average. So I'm using mu. Several of her customers do not believe her. So the chef decides to do a hypothesis test at 10% significance level to persuade them. Saying, no, it is less than 4 ounces. She cooks 14 meatballs. Wow, the chef has a lot of time. The mean weight of the sample meatballs is 3.7. So look what's happening. The chef knows from experience that the standard deviation of a meatballs is zero point 0.5 ounces. They're asking us to calculate the test statistic. Pause here, see what's happening. Let's say you're the chef. You have a big restaurant and you say, the size of the meatballs is not 4 ounces. I know, I'm cooking every day. It's less than 4 ounces. But your staff doesn't believe you. So you can't probably test every meatball there, right? So you take 14 meatballs. And when you weigh the meatballs, you have a 3.7. The weight of the meatballs is 3.7. And the significance level is alpha, 10%. So you're 90% confident about what you're saying, right? Because alpha is 10%. That is the 10% chance that your null hypothesis is true, but you will be rejecting it. That's your alpha. And the standard deviation. The standard deviation is, remember what standard deviation is? It's the average distance from the mean. So if your meatballs are 4 ounces, the standard deviation is 0.5. So you could have 3.5, 3, 2.5, right? So standard deviation is 0.5 ounces. You're moving zero point 0.5. So let's go ahead and take a look at the null hypothesis. Null hypothesis blindly always equal to. And what is the chef claiming? He's saying, hey guys, it's not 4 ounces, it's less than 4 ounces. That's what the chef is claiming, less than 4 ounces. What test less than? Less than is left hand side. Am I moving left hand side to y'all? Probably I am. So left hand side. Left tail test. Alpha, significance level, you can't come up with the number. They have to give it to you. So always look for your alpha. Alpha is 0.1. Now I'm looking for test statistic. Remember, I am not going to be calculating it mathematically. Go ahead, use all the information, plug in your calculator. I will be showing you how to do this in your class calc. Again, I'm going to go ahead and write down my mu is what the meatball is. So the chef claims that the meatball is less than 4 ounces on average. So my mu is 4. Standard deviation, 0.5. So once that's what it is, but the chef is saying, nah, even though you say it's 4 ounces, she takes 14 meatballs. Sample size, 14. And what's the average of those? 3.7 when she weighs the sample. Now let's go ahead and plug this into class calc. Da, 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 da. So here I am in my class calc. You need to start with a graphing calculator. And again, I cannot insist your capabilities of using class calc will not be available if you're not using your graphing calculator. So here I am in my graphing calculator. I'm going to go ahead and click on stats. Oh, I need to click here. Stats. And then I am going to test. Again, graphing, stat, test, and then z-test. Let me go back and do that again. Graphing, stats, test, and z-test. And as you can see, you need to, oh, I think I entered it twice. That's okay. Stats, test, and z-test. And if you look on the screen, you need to enter your values the way they ask you to. The first one is mu, which is the population mean. In my case, it's 4. In our case, it's 4. And then the standard deviation is 0.5. So 0.5. X bar stands for sample mean. She took 14 meatballs and she weighed them and she got 3.7. So 3.7 is the weight of the meatballs. And the sample size is 14. So once you plug all of this in, as you can see, the class calc cleanly gives you the p-values if it's a left-tailed, right-tailed, or two-tailed. As you can see, this is left-tailed, right-tailed, and two-tailed. And this is my z-statistic. So first, let's go ahead and copy down the z-statistic or the test statistic because that's what they ask us to. It's negative 2.244994. And that's all you need for now. Let me go ahead and write that down. So this is negative 2.2449 depending on how many decimal places they are asking you to round off. Fair enough? Again, if you think Miss plugging into the formula is much more easier, go ahead and do that. I have absolutely no problem. Now let's go ahead and see the last problem. Gail, a baker, what's up with bakers and chefs today? Gail, a baker, claims that her bread height is not equal to, let me reduce this a little bit, is not equal to 14 centimeters on average. not equal to. Several of her customers do not believe her, so she decides to do a hypothesis test at 5% significance level. So as you can see, not equal to is giving me a hint that it's a two-tailed test. 14 centimeters is the mean of the bread, and 5% is the significance level. And she wants to do a hypothesis test to persuade them. She bakes 15 loaves, so the the sample size is 15. And the X bar of the loaves that she got is 13.8. Gail knows from experience that the standard deviation of the bread is 0.7 centimeters. So it could be zero point 0.7 moving back and forth, right? In this particular case, they will automatically give you everything. So this should all be given to you in your problem. As we know, it's a two-tailed test from my null and alternative hypothesis. Significance level is always in decimal 0.05. Now let's go ahead and write down all the information. I think my mu is moved up there. So mu is equal to 14 centimeters, right? Standard deviation is 0.7. Sample mean is 13.8. Sample size is she took 15 loaves of bread, so it's 15. You will enter this exactly the way you see into your class calc. Let's go ahead and take a look at the class calc. There is my class calc. I'm going to go ahead and delete this one and start from the beginning. I'm in my graphing, stats. Write this down, please. Graphing, stats, test, and z-test. And once I'm here, my mu is 14. That's the average population mean. 0.7 is my standard deviation. 13.8. 13.8 is my sample mean. And 15 is my sample size. Once I have it, as you can see, my z-value is right here, negative 1.106. I'm going to keep it to 4 decimal places. 3 decimal places is good. 4 actually. So I'm going to go ahead and round that down. So there you go. Again, it's a two-tailed test. So if they ask you for the z-value, which is your test statistic, you simply take your z-value. When they ask you for p-value, you give them the p-value. But in this particular section, we are only asking you for the test statistic. All right. So let me go ahead and write that down. My value, my z test statistic is negative 1.1065, rounding off to negative 1.107. That's my final answer. All right. Again, if you have any questions or concerns, please make sure you email me or contact me through Teams, and good luck.